Okay, hopefully you're catching on to the fact that these all ask very similar things, just they tweak them a little bit. So let's look at this one. This is very similar to number 3. Again, we're given the graph of an original function, and if you kind of glance down at the question, you'll notice we have another function that's defined as an integral again. So it is continuous between -4 and +3, 2 quarter circles in one line segment. G of x is the function 2x plus the integral from 0 to x of f. So let's find g of -3. Part A, g of -3 is equal to 2 times -3 plus the integral from 0 to -3 of f of t dt. Again, I don't like when my limits are backwards. They should always be least to greatest. So I'm going to change that plus to a minus. And I'm going to go left to right here. So from -3 to 0, well, -3 is right here. So we're talking about this quarter circle. So we've got 1/4 pi r squared. This radius would be 3. So 1/4 pi r squared. So we would have -6 minus 9 pi over 4 for g of -3. So you get 1 point for that part. We're not finished with this one. Find g prime of x and evaluate g prime of -3. So anytime they kind of break it up like that, you can about guarantee you're going to get a point for each. So g prime of x, we need to find this in generic terms here. So the derivative of 2x is 2. The derivative of an integral cancels, and we plug in that limit. In this case, it's not applicable, but don't forget that you got to multiply by the derivative of that limit. In this case, the derivative of x is just 1, so it really doesn't matter. Okay, so that's g prime of x. So then it says evaluate g prime of -3, so that would be 2 plus f of -3. F of -3 comes from the graph. F of -3 is 0. So that's 2 plus 0, which is 2. So as I mentioned, you're going to get a point for the g prime of x is equal to 2 plus f of x. Don't just skip that and go straight to g prime of 3. You got to have that on your paper. And then you get 1 point for that answer of 2 for g prime of 3. Part B, determine the x-coordinate of the point at which g has an absolute maximum. So again, write down your thinking, okay? Absolute maximum. Also, don't forget, keyword, absolute. We should be thinking critical points and endpoints. So we need g prime equal to 0. Well, g prime would be 2 plus f of x. We found it in the previous problem. Okay, so if we kind of solve that, this time it's not just where f of x equals 0. That's what it was in the previous problem. But this time it's 2 plus f of x is equal to 0. So really that's saying where f of x is equal to -2. Okay, so you get 1 point for considering g prime is equal to 0. We need to find out where that happens. Well, where does f of x equal -2? So that's got to be right here. Don't fall for that. That's not at a whole number. Okay, that is not at a whole number, so we got to be careful. Look at the slope of this line. This is the line y equals, let's see here, we've got, I don't know, let's just do the entire rise over run here. We were up here at +3, we end up at -3, so that's a rise of -6, and we go over 3, so we've got a slope of -2. That's our slope, not y. So our equation is -2x plus our y-intercept is 3. So where is this equal to -2? So we've got -5 is equal to -2. So 5 over 2 is where this happens. Okay, probably best for this work to be down here in your problem, but I'm showing it over to the side here. And you need to say occurs when x equals 5 over 2. But you can't forget the endpoints. Okay, we're going to have to check We need to check g of -4. And we need to check g of 5/2. And we need to check g of 6. Not 6, 3. Sorry, the interval ends at 3. Now, if you look at the rubric, they don't actually check the endpoints. I don't particularly like that, but technically their logic explains why 5/2 has to be the absolute maximum. And let's look at it. If we are accumulating this area, if we start at -4, we start with some negative area there, right? So we're actually going to go backwards. And then we accumulate a lot of area between -3 and 1.5. And then we go negative again, so we're going to go backwards again. So it makes sense that your maximum is going to be at 5/2. But it's kind of hard, I think, to describe that in words or in symbols as they do. So I would rather you be in the habit, anytime you see those absolute or those extreme words, you got to check your endpoints and you got to check your critical point, and then you compare their values. So that would mean that you need to set up 2 times -4 plus the integral from 0 to -4 of f of t, and you would have to calculate that area. Okay, I'm not going to go through calculating it all, but you would have to do that. So you get the 1 point for considering g prime equals 0. You get the 1 point for your critical point at 5/2, and then you get 1 point for your justification. Okay, so your justification would be plugging in all those values. Let's look at part C. Part C says find all values of x for which the graph of g has a point of inflection. Okay, point of inflection, change in concavity, so g double prime equals 0. So that's where that's where g prime, which equals f, 2 plus f, has a maximum or a minimum. So let's see where we have a maximum or a minimum here. We only have a relative maximum or a minimum at x equals 0. Okay, so g double prime of x equals f prime of x. I would just say that. Therefore, well, no, not therefore. And f has only has a relative maximum and minimum at x equals 0. Therefore, g has a point of inflection. At x equals 0. Okay, 1 point, answer with reason. Okay, 1 pointer there. So if you don't get that one, if that one's a little tricky, it's just a 1 point part of your problem. All right, let's look at D. Find the average rate of change. What should average rate of change make you think? Slope. Okay, average rate of change is slope of f on the interval from -4 to 3. So what is the slope from -4 to 3 of f? We're literally just finding the slope from here to here. So let's set that up. F of 3 minus f of -4 over 3 minus -4. So f of 3 minus, that ends up giving us -2 over 7 is the average rate of change. on the interval from -4 to 3. Okay? 1 point for that. So let's see what the rest of the problem says. There is no point C between -4 and 3 for which f prime of C is equal to the average rate of change. Remember, that's the mean value theorem. Okay? The mean value theorem states that somewhere on the interval, the derivative or the slope of the tangent line is equal to the slope of the secant line. It says, explain why this statement does not contradict the mean value theorem. Well, what were the qualifications for the mean value theorem? You have to be continuous. Okay, no problem. We have to be differentiable. Is there a problem? Yes. We have it's not really a sharp point there, but if you look at the values of the derivative from the left and from the right, from the left, that's going to be 0. From the right, it's going to be the -2. So it's not differentiable. Okay, so you need to say f is not differentiable at every point on the interval -4 to 3. And therefore, the mean value theorem cannot be applied. Now, on the rubric, they specifically state where it's not differentiable. I really don't need to know that you need to do that because I overlooked one. There's also another point where it's not differentiable. Here at -2, there's a vertical tangent line. There's a vertical tangent line, and we have a sharp point. Now, they don't ask you to explain that in depth. They just ask for an explanation. So I think if you just say that it has to be or that it's not differentiable at every point on the interval, therefore it cannot be applied, I think that is acceptable. So you get 1 point for that, 1 point for that.